What is the coldest weather you have endured? No matter how cold, it cannot compare to Antarctica, where temperatures can approach minus 128.6 degrees Fahrenheit or minus 89.2 degrees Celsius. However, the cold in Antarctica is nothing compared to the terrifying new discoveries scientists are making in Antarctica. Even NASA is involved in these amazing discoveries. What have scientists discovered in the cold expanse of Antarctica? How does it affect where you live? Join us as we bring you terrifying new discoveries scientists have made under the ice of Antarctica. Many people know Antarctica is covered in ice. In fact, there is ice as far as your eyes can see in any direction. However, not many people know the place was not always covered in ice. The continent lay over the South Pole without freezing for almost 100 million years. While the South Pole records average winter temperatures of 78 degrees Fahrenheit below zero, evidence suggests that Antarctica used to be as warm as Italy and covered by a green expanse of rainforest. Then, about 34 million years ago, a dramatic shift in climate happened at the boundary between the Eocene and Oligocene epochs. The warm greenhouse climate, stable since the extinction of the dinosaurs, became dramatically colder, creating an ice house at the poles that have continued to the present day. Just what caused the climate shift from rainforest to an icebox is a question scientists are trying to answer. The answer is crucial because it should tell us more about how the climate responds to major controls like changes in the Earth's orbit around the Sun and the concentration of greenhouse gases in the atmosphere. If you wonder how scientists could measure the temperature of Antarctica millions of years ago with a degree of accuracy, they do so by studying tiny microfossils in layers of deep-sea mud. This allows them to record climate changes over a long period. Up until now, scientists found that the oceans appear to have warmed up during this big climactic shift. Their studies suggested that warming coincides with ice sheets appearing in Antarctica and the Arctic. This conflicting evidence of warming seas while ice sheets grew doesn't fit in with computer simulations of the climate at the time. The computer models don't show ice present in the Arctic. The answer to what caused the climate change in Antarctica is taking scientists to the place you least expect. The location has no ice at all and is not even near Antarctica. Scientists are drilling in Tanzania, Africa. The Tanzania Drilling Project team, including scientists from Amguelva, Cymru, and Cardiff University, have been recovering cores of ancient mud deposited on the sea floor millions of years ago, which has been geologically uplifted into land. The Tanzanian cores are unique because large thicknesses of mud were laid down over a relatively short time, meaning that climate changes through time are seen in great detail. Also, beautifully preserved microfossils are found in the cores. The Tanzanian cores provide the first really clear picture of how sea level fall fits in with the climate shift. The chemistry of the Tanzanian microfossils has been used to construct temperature and ice volume records throughout the big climate switch. These new records show that the world's oceans did cool as the ice sheets appeared and that the volume of ice would have fitted onto Antarctica. So the computer simulations of climate and the past climate data now match up. However, the work of scientists is not yet done. Their focus now is to look for evidence of the ultimate cause of this global cooling. The prime suspect is a gradual reduction of CO2 in the atmosphere, combined with a trigger time when Earth's orbit around the Sun made Antarctic summers cold enough for ice to remain frozen all year round. Now, it is no secret that Antarctica is shrinking thanks to global warming. Another group of scientists has been busy in the Antarctic trying to determine if, due to this global warming, the Antarctic could return to its pre-ice state and what that could mean for you and everybody else on this planet, whether you should be scared or not. One of the scientists is Jonathan P. Klagers, a marine geologist who helps to unearth fossils. He and his team work on the RV Polarstern, a research icebreaker ship that regularly carries around 50 scientists and 50 crew members to the Arctic and Antarctic. Klagers and his team have been drilling into the sea floor. Thanks to the enormous and powerful drill, their drilling area allows them access to layers of 90-million-year-old sediment or strata. According to Klagers, the layers are important because they are like the pages in a book. As you walk through the page, you walk through history. Klagers is excited by the expeditions he's been a part of because everywhere they went, they were the first to get there, meaning they're discovering new things all the time. Polarstern is one of the largest research icebreakers in the world. In fact, it can break through enormously thick ice. That makes it possible to reach locations usually not reachable for other ships. Operating the rig on the Polarstern is no mean feat. It is almost 10 tons and needs 7 20-foot containers of equipment to be shipped ahead. The drill rig needs special conditions. It sits on the seafloor and is connected with a long cable about 1,000 meters for power supply. There is another glass fiber cable that handles the communication. Clark's team had 8 HD cameras observing each step. In their recent expedition, Clark and co. returned to a site where they had seen tilted geological strata. Tilted strata suggest some kind of bigger tectonic process brought it up, and it can reveal how old it is. The seafloor drill rig has 2 magazines in it, one with empty barrels and one with filled barrels. The inner barrel is pulled out every 3.5 meters and the sample is kept. Clark and his team then got the material from the technicians. Mind you, the technicians handle the drilling and not the scientists because of the complexity. One of the samples generated excitement as the team could see they had something special. The sample had a color that they had never seen before in Antarctica. It was a very dark brown and very fine-grained. They could see black spots and were wondering what they were. Their initial suspicion was the spots were organic in origin. After the crew returned home, the samples returned a couple of weeks later and shipped home on Polarstern. Clarkers then decided to go to a hospital they collaborate with that has human-computed tomography or CT scanners. The CT data confirmed their initial suspicion of the black spots being of an organic origin. They were an interconnected network of fossil roots. That was the closest evidence of plant life to the South Pole. Before Clark's discovery, all other plant evidence was between 1,000 kilometers and 1,500 kilometers away from the South Pole. However, Clark's team found the fossil roots only 900 kilometers away from the South Pole. No one really knew what the climate was like during the super greenhouse period near the South Pole, but this is actually what you need when you want to know the severity of a particular climate in Earth's past. The poles are warming much more quickly than the rest of the planet, and as polar ice melts, global warming accelerates. Clark's study could reveal exactly that. What is the widest and deepest hole you have ever seen? No matter the dimensions, nothing prepares you for the ice cave under the Thwaites Glacier in West Antarctica, one of the most challenging places to reach on Earth. This cave is 2/3 the size of Manhattan and about 1,000 feet or 300 meters tall. NASA had a hand in discovering this massive cave because its scientists found it. But how does such an immense gap form? Surprisingly, the cave formed recently from ice that melted. The team of scientists investigated with ice-penetrating satellite-based radar and calculated the void once held over 15 billion tons, or 13.6 billion metric tons of ice. The gap is large enough to have been contributing to the glacier's movement. What is mind-bending is that this giant void is growing, and the expansion is making the ice above it melt rapidly. This is because as more heat and water get under the glacier, it melts faster. The scientists were also assisted by data from a constellation of Italian and German spacecraft that is equipped with a synthetic aperture radar instrument that can measure how the ground surface has shifted between images. The data showed that the ground had shifted substantially between 1992 and 2017. Thwaites Glacier, even though remote, affects the rest of the world, which is why this massive void is significant. It's about the size of Florida and is currently responsible for roughly 4% of global sea rise. So if the entire glacier were to melt, the resulting water could raise world ocean levels by more than 2 feet or 65 centimeters. Apart from this, the glacier acts as a backstop for neighboring glaciers, meaning that it slows the rate at which they lose ice. If those glaciers melted too, sea levels could increase a whopping 8 feet or 2.4 meters. The next mystery of Antarctica is actually something you can enjoy yourself: Blood Fall. You can book your trip to the South Pole, where in the McMurdo Dry Valley, a bright crimson 5-story waterfall pours out of Taylor Glacier into Lake Bonny. It looks like a gush of blood from a wound in the ice, but scientists have recently discovered the cause behind this mysterious phenomenon. Here is the explanation. The water that feeds Blood Falls was once a salty lake that is now cut off from the atmosphere due to the formation of glaciers on top of the lake. The water is preserved 400 meters underground and has become even saltier over time. Right now, it is 3 times saltier than seawater and cannot freeze. The salt water is also extremely rich in iron and completely devoid of oxygen and sunlight. As the iron-rich water seeps through a fissure in the glacier and comes into contact with the air, the iron oxidizes and rusts, staining the water a dark red color. You will need a helicopter ride or to get on a boat visiting the Ross Sea to enjoy this spectacle. The next surprising discovery in Antarctica includes the former occupants. As mentioned before, Antarctica was not always a box of ice. It was so warm that it supported lush plant life and the legends of the past, dinosaurs. It's hard to imagine a dinosaur trudging over the ice, but scientists discovered the remains of an iguana-like Triassic, which called the continent its home. The reptile has been dubbed Antarctinax shackletoni, and it lived more than 250 million years ago. It was an archosaur, a precursor to the lineage that would branch into dinosaurs, pterosaurs, and crocodilians. The animal probably grew to 4 to 5 feet, or 1.2 to 1.5 meters long. However, Antarctica has other former tenants, including what is basically a Loch Ness monster. This is the world's heaviest elasmosaurid, a plesiosaur of the genus Aristonectes. Paleontologists discovered the long-necked sea creature on Antarctica's Seymour Island in 1989, but they weren't able to finish excavating the enormous fossil until 2017. In total, they dug up 1,760 pounds or 800 kilograms. After examining the specimen, the researchers described the beast this year for the first time. While alive, the Antarctic Loch Ness monster would have been 36 feet or 11 meters long and weighed a massive 15 tons. The creature lived only a few tens of thousands of years before the Cretaceous Paleogene extinction 66 million years ago, when an asteroid collided with Earth and wiped out the non-avian dinosaurs. The next mystery of Antarctica is an audio one because it consists of a massive slab of ice that is singing. The Ross Ice Shelf is the largest ice shelf in Antarctica. It is several hundred meters thick and covers over 500,000 square kilometers. That is roughly the size of France. Scientists recently discovered that the Ross Ice Shelf sings an eerie melody caused by the winds blowing across the snow dunes. The winds create surface vibrations and almost non-stop seismic tones. The vibrations aren't audible to human ears, and scientists use seismic sensors to listen to the mournful tune. The song was discovered by accident after seismic sensors were installed on the ice shelf to observe other behaviors. Scientists have since discovered that the song changes in response to the environment, such as melting or storms shifting the snow. They're now using the song to monitor the ice shelf in real time, tracking its stability and vulnerability to collapse through the seismic humming. Antarctica is home to lots of ice, which is very cold, but it is also home to what is on the extreme end of the temperature scale: lava lakes. Lava lakes are even common because there are only 8 of them in the world, so it's a big deal that one of them is located in Antarctica. The lava lake is found in Saunders Island, a volcanic protuberance in the South Sandwich Islands. It is contained in an icy crag known as Mount Michael, the highest volcanic mountain in the area. Scientists discovered the crater lake with the help of thermal imaging from satellite data. Unlike most exposed lava on the Earth's surface, the lake remains molten. Its temperature in the lake reaches between 1,812 and 2,334 degrees Fahrenheit, or 989 and 1,279 degrees Celsius. The next discovery in Antarctica is the stuff of conspiracy theories, and if you're a fan, it's for you. What are the odds of finding a sharp-cornered tabular ice formation in the middle of the ice-cold continent? That was the question many people were asking when pictures taken during a research flight surfaced on the internet. The picture was taken by NASA scientist Jeremy Harbeck. Yes, you can't separate the space agency from conspiracies, and showed 2 tabular bergs bobbing in the frigid sea. These are not tiny structures as you might assume from the pictures. For instance, one of them, named A68, is about the size of the state of Delaware. The truth, however, is that wind and water sculpt Antarctica's ice into strange shapes. These rectangular chunks are actually shards created by the carving of a huge iceberg. With time, erosion will alter the sharp edges. Now, what is the color of ice? While you may struggle to provide an answer, the Antarctic boasts green ice. It is not difficult to make green ice with the help of a deep freezer, but when nature makes it unassisted, the story changes. One of the scientists trying to unravel the mystery of green icebergs is Stephen Warren, a glaciologist at the University of Washington, and he has spent more than 30 years on it. The first time he took samples for a study was in 1988 near the Emery Ice Shelf in East Antarctica. Most glacial ice occurs in shades of white to brilliant blue. The bluer the ice, the older it is typically. Compression from accumulating layers of snow pushes air bubbles out of the ice, reducing the scattering of white light. The compressed ice absorbs most of the light spectrum except for blue, creating the otherworldly turquoise seen in the hearts of icebergs and glaciers. One clue that could help Warren is that the green ice came from marine ice and not glaciers. This led them to believe the green coloration was coming from organic materials stuck in the ice. However, subsequent research showed that the green marine ice didn't have a higher than usual amount of organic impurities. The results of further research now suggest that a different sort of impurity may be the root cause of the green ice: iron oxide. Warren and his colleagues discovered that the marine ice at the bottom of the Emery Ice Shelf has 500 times more iron than the glacial ice above. This iron comes from the rocks under the Antarctic ice sheet, which is ground into a fine powder as glaciers move over them. The ice-bound iron oxidizes as it contacts seawater. The resulting iron oxide particles take on a green hue when light scatters through them. When icebergs break off the larger ice shelf, they carry this iron-rich ice and the brilliant color with them. This, though, is not a foregone conclusion, as Warren and his team have to do further research to reach a definitive conclusion. What has NASA been doing in Antarctica? Looking down from the above, you might think the Antarctic ice sheet looks like a calm, perpetual ice blanket that has covered Antarctica for millions of years. But don't be surprised that the ice sheet can be thousands of meters deep at its thickest and hides hundreds of meltwater lakes where its base meets the continent's bedrock. Now, using the most advanced Earth-observing laser instrument NASA has ever flown in space, scientists have improved their maps of these hidden lake systems under the West Antarctic ice sheet and have discovered two more of these active subglacial lakes named Conway and Mercer. The new study provides critical insight for spotting new subglacial lakes from space and assessing how this hidden plumbing system influences the speed at which ice slips into the Southern Ocean, adding fresh water that may alter its circulation and ecosystems. With NASA's Ice Cloud and Land Elevation Satellite 2, or ICESat-2, scientists have been able to precisely map the subglacial lakes. The satellite measures the height of the ice surface, which, despite its enormous thickness, rises or falls as lakes fill or empty under the ice sheet. The study, published in Geophysical Research Letters, integrates height data from ICESat-2's predecessor, the original ICESat mission, and the European Space Agency's satellite dedicated to monitoring polar ice thickness, Cryosat-2. Hydrology systems under the Antarctic ice sheet have been a mystery for decades. That began to change in 2007 when Helen Amanda Fricker, a glaciologist at Scripps Institution of Oceanography at the University of California, San Diego, made a breakthrough that helped update classical understanding of subglacial lakes in Antarctica. Using data from the original ICESat in 2007, Fricker found for the first time that under Antarctica's fast-flowing ice streams, an entire network of lakes connects, filling and draining actively over time. Before, these lakes were thought to hold meltwater statically without filling and draining. The original ICESat mission is credited with discovering the interconnected systems of lakes at the ice-bed interface that are moving water around, allowing scientists to study all the impacts on glaciology, microbiology, and oceanography. However, with the ICESat-2, scientists had a powerful tool that yielded data so high in precision that they were able to start mapping out the lake boundaries on the surface. Scientists have hypothesized subglacial water exchange in Antarctica results from a combination of factors, including fluctuations in the pressure exerted by the massive weight of the ice above, the friction between the bed of the ice sheet and the rocks beneath, and heat coming up from the earth below that is insulated by the thickness of the ice. That's a stark contrast from the Greenland ice sheet, where lakes at the bed of the ice fill with meltwater that is drained through cracks and holes in the surface. How deep below the surface are the Conway and Mercer lakes? These hidden gems of frigid water hidden beneath 1.2 to 2.5 miles or 2 to 4 kilometers of ice on the southernmost continent. They fill and drain over and over again in largely mysterious cycles that may influence how fast the ice sheet moves and how and where meltwater reaches the Southern Ocean. This flow in turn can change the currents in the Southern Ocean and potentially affect ocean circulation worldwide. Unlike most lakes on the surface that remain in a place for years, this underground water system is dynamic or highly fluid, pun intended. By combining data from multiple satellites from 2003 to 2020, scientists have been able to trace changes in the subglacial lake system between those years. They focused on 3 areas with good satellite coverage and known active lakes: the boundary between the Mercer and Whillans ice streams in West Antarctica, the lower McHale ice stream, also in West Antarctica, and the upper Academy Glacier in East Antarctica. At the Mercer and Whillans boundary, the researchers found 2 new lakes, which they dubbed the Lower Conway Subglacial Lake and the Lower Mercer Subglacial Lake. They also found that what was thought to be 1 lake under the McHale ice stream was actually 2. Over time, these lakes experienced major change. For example, the lakes beneath the Mercer and Whillans ice stream boundary have undergone at least 3 periods of drainage in 17 years. Meanwhile, all of the lakes beneath the McHale ice stream have followed their own patterns of draining and filling. The lowermost lake went through 4 fill drain events during the study period, each taking only about a year to complete. The second lake drained between 2014 and 2015 and had been filling up again, while the third lake drained just slightly between 2016 and 2017. Meanwhile, the lakes beneath the Academy Glacier drained between 2009 and 2018. All of these changes are puzzle pieces in scientists' understanding of the speed and direction of Antarctica's ice sheet flow. Already, researchers are finding the links between the under-ice lakes and the ocean. In January last year, a study co-authored found that the drainage of 1 lake on the Amory ice shelf in East Antarctica flushed as much as 198 billion gallons, or 750 billion liters, into the ocean in only 3 days, as reported by Live Science. While it is fascinating to find lakes buried deep underneath the ice in the Antarctic, one question you might be asking is whether there is life in that lake. The environment is harsh enough on the surface, but can life survive deep down in the 2 newly discovered lakes? Expedition leader John Priscu, a professor of polar ecology at the University of Montana, answers that early studies of water samples taken from Lake Mercer showed that they contained approximately 10,000 bacterial cells per millimeter. While that is only about 1% of the 1 million microbial cells per millimeter typically found in the open ocean, it remains a remarkable find for a sunless body of water buried deep beneath an Antarctic glacier. But that is not the end, because the high levels of bacterial life in the dark and deeply buried lakes are signs that it might support higher life forms, such as microscopic animals like tardigrades. Meanwhile, the abundance of bacterial life in Lake Mercer mirrored the discovery of high levels of bacterial life in Antarctica's nearby subglacial Lake Whillans in 2013 in an expedition that Priscu also led. Scientists theorize that the bacteria in Lake Whillans and possibly Lake Mercer are surviving on deposits of carbon laid down by photosynthesizing organisms between 5,000 and 10,000 years ago, when the buried lakes may have been connected to the open ocean. During their stay on the ice from mid-December last year, the expedition team used drills and hot water to open a borehole from their camp at the frozen surface down to the buried lake of liquid water. The drill team bored through about 3,504 feet or 1,068 meters of ice, and the water below was a chilly 30.8 degrees Fahrenheit or minus 0.65 degrees Celsius, so that scientific researchers could take water samples and sediment cores from the lake, which was about 49 feet or 15 meters deep at that spot. The team had also lowered a specialized remotely operated underwater vehicle or ROV into the dark waters of the buried lake, as well as several cameras, which they used to take images and make a video of the lake floor. The discovery has implications for the search for life on other planets, particularly on planet Mars, where signs of a buried lake of liquid salt water were seen in data reported in 2018 by the European Space Agency's orbiting Mars Express spacecraft. In fact, Priscu thinks that any life below the frozen surface of the planet Mars might follow the patterns seen in Antarctica's subglacial lake. Next, have you heard of polynyas? You probably haven't, but they are real in the Antarctic. So what are polynyas? They're gaping holes, and they pop up even during winter when the ice pack in the continent is the thickest. These enormous holes have been popping up sporadically with no observable pattern since the 70s. For decades, their origin had remained mysterious, even though scientists had been investigating them. There was renewed interest in polynyas recently when 2 very large ones opened up in the Weddell Sea. In one of them, the open waters stretched over 115,097 square miles, or 298,100 square kilometers, as reported in geophysical research letters. Researchers predict that polynyas, which means open water in Russian, can modify weather patterns in Antarctica or even outside of the continent. This is why it is important to understand them. Thanks to floating robots and gadgets mounted on seals, scientists seem closer to the answer of where polynyas come from. Results from studying ocean conditions and the formation of polynyas show that these stretches of open water expand due to short timescale climate variations and nasty weather. They also discovered that polynyas release tons of deep ocean heat into the atmosphere. Research is still going on concerning the consequences of polynyas. One of the suspected effects is climate change. This means polynyas can affect you anywhere you live on the planet, even though they are located many miles away from you. But how so? This is because the deep ocean water exposed to the atmosphere during a polynya is potentially carbon-rich. Deep Antarctic waters are actually the graveyards for marine life, which release carbon as they decay. If that carbon ends up in the atmosphere via polynyas, these open water openings could contribute to climate change. So what is the oldest item in your possession? How old is it? If you come to Antarctica, you will find something older than the sun. However, you will have to come with a powerful magnifier to see it. This is stardust, formed from when a star experiences an explosion known as a nova. But how did stardust end up in Antarctica? You might not know this, but meteorite hunters are fond of Antarctica. This is because the space rocks that land there accumulate in glaciers and tend to become concentrated. So recently, one of the meteorites turned up something remarkable, as one of its grains, which is about an inch divided by 25,000 in size, proved to be a speck of stardust. The grain, which looks like a croissant when enlarged, tells us the story of our universe. It is made up of a combination of graphites and silicate. Nova explosions occur in the exchange of energy between an ordinary star and a white dwarf, or a star that has burned off most of its nuclear fuel. So the white dwarf feeds off the other star, accreting enough new material to reignite itself in powerful outbursts that then spew material into space. This is how the sample of stardust named LAP-149 formed and then made its way through interstellar space to the vicinity of our solar system. These star explosions provide ingredients that are used to form new planets, so studying this old grain gives a clue to what our universe looked like in the past. Scientists estimate that it's not less than 4.5 billion years old. Let's hear the discovery in Antarctica that is the most fascinating to you in the comments section below.